The last session was about the table distribution. So we saw there are four type of table distributions available in AWS Redshift. The first one is the event distribution, where we follow the round robin fashion. Then we have the key distribution where data is get distributed according to the one value in a column, and then we have the all distribution where we distribute entire table, all the records, all the rows across all the nodes to the first node slice of that compute node. And then we have the auto table distribution where cluster itself decide, uh, so it keeps the all distribution initially, and as soon as soon your table grows, it change it to the even distribution, and it do not perform the same task vice versa from like even to all. So that was the table distribution. So you know like how powerful table distribution is. So with table distribution, we actually control the data across all the compute nodes. So we decide how data uh, evenly, we try to keep data as even as possible across all the nodes. So it will be it will be available for all the joins, it will be available for all the retrieval, and there should be minimal broadcasting, there should be minimal redistribution. So that was the recap of the last session, that was about the table distribution. Now, so there is one more differentiating thing which is there with the AWS Redshift. So that is called a sort key. So Redshift sort key determines the order in which the rows in a table are sorted. So it is the order in which the table available in a row are stored on a disk physically. So this shortcut defines how your table rows are actually, in which order they are stored on your disk. So that's the work of your sort key. So it defines the order in which your rows records are actually on your disk, on your storage disk, physically stored. So it tells the leader node that this is the order in which records are stored. Now you imagine, if you know the order, how beneficial and how superb it will be to retrieve the data. If I know I have 10 employees and the employee ID starts with like 10121010, and if I know, okay, so my record are stored in a like say ascending or descending order, or say from like 1012 102 1012 1010. Now this thing I know, right? And now I have to find the name of a person whose employee ID is 104. Okay, so what I am going to do, it's like partitioning. It's like I have the index, I know that this is the order. Okay, my records are stored in 10 from 1012 1010 in that order. So I don't have to scan all the 10 record, right? If I say all the if I say these 10 records, these 10 columns, sorry, these 10 records are stored in 2 blocks, so I know I don't have to scan the second block, because my records are already in the ascending order, and I am looking for 104, and my records are stored in 2 blocks, so I have to scan only one block. You see like what I am doing, I am just filtering out the entire block, one block. So it's an improvement. So it's very efficient to know the order of your data, the way it is stored. So that is the function of sort key. So query performance is improved when the sort keys are properly used, as it enabled the query planner to read fewer chunks of data, filtering out the majority of data. So what we did, we filter out the entire one block, because I was looking for 104 employee ID. So I know if it is in ascending order, it will be there in the first block. So that's the work of sort key. So Redshift sort keys allows keeping large chunk of data during the query processing. Fewer data to scan means a shorter shorter query processing time, thereby improving the query's performance. Redshift short key, there can be multiple column define, so you can define short keys on multiple column. The data stored in the table can be sorted using these columns. The query optimizer uses this sort key order, sort table order, during determining the optimal query plan. So actually you can define the sort key on couple of columns, so all that can combine, and according to that key other records can get sorted out. It can like have that order like ascending or descending according to the column that you select. So there are two type of sort keys available in AWS Redshift. The first one is the compound and second one is the interlude sort key. Okay, so okay, I just explained what short key is, but even if if you didn't catch that, let me explain you with this small example. Okay, so see, this is let's say I have a employee table where there are two columns, employee ID and the employee name. Okay, and this is how my records are. This is not in order, right? And now if I have to find 104, I want to know where the employee ID is equal to 104. What is the name of employee ID? No, where the ID is equal to 104. Okay, so I'm looking for this record. So what will happen if it is not in sorted order? I have to scan everything, right? I have to scan both the block. Now just imagine these records are stored in first block and this record are stored in second block. So my query has to scan everything. Now what I do, let me define a short key on a ID column. So this is what actually happen in AWS Redshift also when you define a short key on your employee column in a Redshift. So now I say ID is my short key column, and I define short key on ID column. So this will what happen, say like from ascending to descending. Now it is asking for expand the selection. Yes, I say yes. Now you see this is what happen when you define a short key on your ID column. All the other records related to all the ID all will be in order. Now this is how exactly your data will be stored on your disk. Now okay, now I run the query. Same query, I say select name from employee table where ID is equal to 104. So now you see this in this situation what it will do. It doesn't has it the query will not going to scan the other block. I will get my records from the first block. So it filter out data. So that's the short key. If I do the same thing, if I say salary for all these employees, say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, so this is defining the short key on one column, right? If I select the two column and if I say okay, sort it on the two columns. So like I selected two columns, right? So this is the compound thing, right? I'm doing the clubbing, right? So on the basis of this two column, my entire other records will get sorted. So this is like 101. This is 101 is the ID and the employee name is Roshan and the salary is 1. Okay. So if I select it on two column, so this record will be stored according to these two values. So these are the options available with the short keys. So we're going to see like how like the compound sort key and the interlude sort keys are different. Now so with this exercise, with this Excel, when we said like defined sort key on id column. So you saw that all the names changed in order to the ids, right? So that's what actually the work of sort keys. Now then there is the compounding, where we can add the multiple columns. Okay, so there are two types, the compound sort key and the interlude sort key. Okay, now compound sort key. So compound sort keys are made up of all the column in a list in the Redshift definition during the creation of table in the order they are listed. Okay, so it is nothing, compound is nothing but the multiple things, right? So when you define a sort key, you can specify multiple column. Okay, so this is the syntax. Okay, when we create a table, we can say okay, compound sort key and the customer id and the customer country id. Okay, but in a compound sort key, the order is very important. So what you said, customer id is my first criteria and the country id is my second criteria. So you know what happened in sort key, compound sort key, the 80% weightage is given to the customer id and 20% weightage is given to the country id. Okay, so compound sort key is exactly the way, the order in which it is defined. Okay, so that the order is very important. It is advisable to put most frequently used column at the first in the list, because I told you, right, it is, we are giving 80% weightage to the first column and then to 20% weightage to the other column. Compound is default sort key type. The compound sort keys might speed up the group by, the join, order by operation, and the Windows functions are like such as partition by. So for like group by, partition by, order by, like this compound sort key is very important. Okay, now let's see like what's the thing with interlude sort key. So interlude sort key is again the same, there's no difference. Instead of compound, you just mention the interlude sort key and you just mention the column name. What will happen in this case, like equal weightage will be given to the customer id and the country id. So here if you change the sequence, it will not matter, like all equal weightage, instead of 80-20, here it will be 50-50. So that's the difference between the sort key and the compound sort key. So interlude sort key gives the equal weight to each column in the Redshift sort key definition. As a result, it can significantly improve the query performance, where the query uses the restrictive predicates equality operator in where clause on the secondary sort column also. So here if you say like a country customer id is equal to 101 or the country is equal to India, improvement, the performance will be the same. But if you do the same thing here in the compound sort key, it will not be right. When you say customer id is equal to 101, you will get very reports will be very easily retrieved versus the customer id, because here the order in which it is defined that matters a lot. Here it gives the equal weightage in interlude sort key. Okay, so adding root to a sorted table already containing data affects the performance significantly. Vacuum and analyze operations should be used regularly to resort and update the statistical metadata for the query planner. The effect is greater when the table uses the interlude sort key, especially when the short columns includes the data that increases monotonically, such as the date or the timestamp column. So let's create, so this is the definition, this is how we define it. Okay, now so just hold on this part, vacuum and analyze. We have entire session on this topic, for this is against very good thing. So for now, so just if I say compound short key versus interlude short key, so for now, right now the understanding should be like the weightage. In compound sort key, like we give the order in which it is defined, that matter a lot, and in interlude sort key it has given equal weightage. Okay, now let me give you the example. See, for I have a table. Okay, I have a table, and in that table I'm holding the revenue, global revenue. See, the name of a table is the global revenue table. Okay, in this global revenue table I have customer ID. Okay, then I have the market segment, then I have countries, and then I have revenue. Okay, now my marketing team, my global marketing team want to know the customer wise, segment wise, country wise, the country wise revenue. So what will happen if you say, if you define a composite key on this column mentioning your customer ID column, your segment column, your country column in your composite key definition. Okay, see, in composite key definition order is very important. So what I'm saying, customer ID, then your market segment, and then your country. Now when you run a query, select revenue from global revenue table where customer ID is greater than 1002. Okay, so what will happen in when this query will run, the first column in the composite key definition is the customer ID column. This query will run like a star. It will retrieve like result very fast. But when I say select revenue from global revenue table where customer ID is equal to 1002 and the market segment is equal to furniture. Now here is the problem. In composite key, 80% weightage will be given to the customer ID, and remaining for all remaining two column, 20% weightage will be there. Your query will perform poorly. Now let's do the same thing with the interlude key. When you run the same query, say select revenue from global revenue table where customer ID is greater than 1002. In this case, interlude key will take more time, but when you add another filter, say customer segment is equal to furniture, it will work like a star. It will give you record super fast. And if you add one more filter saying country is equal to India, even in that case your interlude key will work like anything. So it will be superb in such a scenario. So it's all different, right? How we define the short keys according to the business requirement, according to our table definitions, and what report we are trying to retrieve. So for now, there are like we have short key in AWS Redshift. I just gave you small demo with Excel what actually happened and how data is actually stored to the disk when we define a short key on one column. And then there are the composite short key, and then there are two type of short keys. We have composite short keys, composite short key, and interlude short keys. And I give you the basic difference what will happen if we define the compound short key versus interlude short key. And with interlude short key, the overhead is more because it has to rearrange the lot of data in a column. So that's the thing with the interlude short key and the compound short key. Now there are some basic rules to define short key for a table. So let me give you the thumb rules. So the thumb rules is like where clause, then your joining column, and then your timestamp. So these are the three things. If you see, if you are filtering your data using the where clause for specific column, then that column will be the right candidate for the short key. If you are doing a frequent join on one specific column, then that column will be your right candidate for the short key. And if you are doing the range filtering, right, if you are filtering out the data like 2000 less than 2010, then you greater than 2010, like that. Then that timestamp column will be, or that range filtering column will be the right criteria for your short key. So this is what this rule says. If the recent data is required more frequently, specify timestamp column as the leading column of your sort key. If you do the frequent range filtering or equality filtering on one column, specify that column as a sort key. If you frequently join a table, specify the join column as a both the short key and the distribution key. Now, use interlude short key when you plan to use one column as a short key, or when where clause is in your query have high selective restrictive predicates. Okay, so in that scenario you can use the interlude short key. Or if the table are huge, you may want to check the table statistics by querying the STV block list system table. Look at the table with the high number of 1 MB block per slice and distributed over all the slices. So these are the things that we have in place. So we'll be having hands-on on all these things, how to check, how to use the system tables and check the statistic. But for now, like if I'm using multiple filters in my business query frequently, and the weight is supposed to be equal on all the columns, then in that case I'll for sure go along with the interlude sort key. And use the compound sort key when you have more than one column as a sort key, when your query includes join. So if you are using so many join, the group by, order by, partition by, so yes, join, group by, order by, partition by, compound sort key. If you are doing so many group by, join, order by, then the compound sort key will be perfectly fine in that situation, because it again like improve the group by operation. Because like in the group by, like we do the same thing. The first column we define, so it does the calculation on the first column, and then the second column, and then the third column. Yeah, so I hope like we have like at least idea about the compound and the interlude sort key, and what actually sort key does, how data physically stored in the sorted order if we use the sort key. So this is like very important and very important and very efficient feature that the Redshift has, and it's drastically changed the query performance. Cause like in when you know the order, it's easy to find out the records, skip the multiple blocks and scan the exact zone. Again, like we have so many things, like we have Zmax, Gmin for each block. We have that things. So for each 1 MB block, Redshift gives the Zmap and zone map ID, minimum zone map ID and maximum zone map ID. And then like whenever you run the query, it checks that zone map ID. So that all are like the tuning performance things. So now we are going with the basics of Redshift. So once we cover this couple of things sessions, so we'll start working on it, and then like we'll be having fun. So we'll do we'll run queries to so many system tables, views. We'll get the data, we'll define the keys, short keys, table distribution, and all over. So we'll be doing that slowly in next sessions. So this session was this was quick session, and this session was about the table sort keys. So next section, we will cover the vacuum and analyze, so which is the part of maintenance. And so like when we start with AWS Redshift, so these are the things we should know, like what is the architecture, what data type it supports, what is table distribution, what is short key, and what is like vacuum and analyze. So in next section we will be covering like vacuum and analyze. Both the operations are very important and both the operations are required. So once we complete with vacuum and analyze part, we will start doing the practicals. Then we will log into the console. One session we will be having on the console monitoring, the things we can do with the console, and then we will slowly go with the user management, unload, copy, serializable isolation, and likewise. So for this session I'm concluding over here. So see you in the next session. Thank you. Have a great